finish solving. So this whole triad basically is solving one-step equations and then operations on fractions. So we're going to finish up with this and take a test over all this on Friday. So let's take a look at the first two problems here. We have negative 40 equals negative 6a. I'm just going to kind of call on you guys around the room, so be prepared for when I call on you to tell me what to do. So we don't want to lose easy points here, so we're going to circle the variable, draw my line of equality. My goal is to get the variable by itself. So in order to get the variable by itself, I have to get rid of that negative 6. How do I get rid of that negative 6, Darius?
Let's see.
Take a look at that again. What's that 6 touching?
9.
So anytime a number is touching a variable, what does that mean to do?
Divide.
It means to multiply, which the opposite of multiply is divide. So we're going to divide each side by negative 6. Okay? So I'm going to bring down my variable a, my equal sign on my line of equality. Then I'm going to take negative 40 divided by negative 6. What happens when I do that, Brendan? What happens when I take negative 40 divided by negative 6? I'm going to come up with a decimal. Don't want a decimal answer. So I'm going to go ahead and leave this as a fraction. Couple things I need to do in order to leave this as a fraction. Raise your hand if you know the first thing I have to do. Darius? That's okay. Rihanna, can you help him? Okay, one of the things we're going to do is simplify. Beyonce, what's the other thing?
The negative can't be at the bottom.
Okay, the negative can't be at the bottom. But what do you guys notice here? How many negatives do I have? 2 negatives equal what? Positive. So I can just drop those negatives all together. So I'm just going to drop those negatives off all together. I'm going to come down here and write. So I'm going to have 40 over 6. 40 over 6 can be reduced. What's 40 and 6 both divisible by? 2. So I'm going to take 40 divided by 2 and get 20. 6 divided by 2 and get 3. Can I reduce it further? No. So 20 over 3 is going to equal a. So if you missed that one, make sure you go back through and you correct it, and you show your work corrected. Why do you keep putting this back on your desk? Put that in your folder. You know how many times I passed this back out to you? I think like 3. All right, let's take a look at the next one. We have b plus 7 equals 4. How do I get the b by itself here, Jemiah? So I'm going to minus 7 on each side. Cancel. Bring down my variable b. Jemiah, what's 4 minus 7? 3. Just like that? Okay. So if I have $4, can I give you 7? No. So what type of 3 is this going to have to be? A negative. All right. Moving on to fractions. Bless you. So we have c plus 4 over 9 equals 1 over 9. When I add and subtract fractions, what do they have to have? Anybody? When I add and subtract fractions, what must they have? Say it again? Or are you just mumbling to yourself? I thought you said it. Yeah, same denominator, common denominator. Well, with this particular fraction, they have the same denominator. So how do I get the c by itself, Asia? So how do I get this variable c by itself? So what's the opposite of plus? Okay, so I'm going to subtract 4 9s from each side. I know you can be louder than that. I've heard you in the hallway. Bring your variable down. C equals. So now that I have common denominators, I don't need to do anything to it. So what's 1 minus 4? 1 minus 4. Beyonce? 3. What type of 3? It's going to be a negative 3 over 9. What can negative 3 over 9 be reduced by? 3. So negative 3 divided by 3 is? And then 9 divided by 3 is? So my answer is going to be C equals negative 1 over 3. Because 1 is in the numerator, do I need to keep that 1 there? Yeah. But if it was in the denominator, would I need to keep it?
No.
No. Any questions on the first 3? All right, go ahead and flip your openers to the back. Let's finish the last 3. All right, we have 4 over 5 equals D over 10. How do I get the D by itself here, Kelsey? Yeah, I'm going to multiply by 10. I'm going to run out of room here. So I'm going to drop down to the bottom and write my work down here at the bottom. So I'm going to show that my 10s cancel. Bring down my variable D equals. So I'm going to show my work down here in the red.
I thought it was cross multiplication.
So I have 10 times 4 over 5. Say it again. No. Oh.
Yeah.
I wonder if that'll work out.
Yeah.
I bet you thought it was a proportion.
No, I thought it was cross multiplication.
Pi d. Let's do it my way first, and then we'll cross multiply and see if we end up with the same answer. Okay, so I have a whole number times a fraction. In order to change a whole number to a fraction, what do I put up under it? A 1. When I multiply fractions, I like to reduce the beginning. Can I reduce any numerator with any denominator here? Yeah, what? And? 10. What are they both divisible by? 5. So what's 10 divided by 5? 5 divided by 5? 1. Can I reduce anything else? No. Okay, so we'll go ahead and multiply our numerator. So what's 2 times 4? 8. What's 1 times 1? Do I need to put it 8 over 1 like that? No. I can, but because I want it in simplest form, I'm going to leave it like that.
We got the same
Yeah, we got the same answer.
Okay, so last week we took notes on Khan Academy solving proportions, right? So if you look at this one here, it does resemble a proportion. So you could have solved it in that manner too and still had an acceptable answer. Do you guys know what I'm talking about? Are you just saying that so I don't show you?
Yes.
You don't. Hey, you know, I respect honesty. Don't write what I'm writing. I'm going to do it super fast. 4/5 equals D over 10. So what Rihanna and Darius were saying over here, they cross multiplied. So they took 4 times 10 and got 40 equals, then they took 5 times D and got 5D. Well, now you have a one-step equation here. Circle my variable, draw my line, get the D by itself, cross 40 divided by 5 is 8. So either way would have been acceptable. Okay, erase. Uh-oh, my eraser disappeared. There it is. Okay, the next 2 problems are a little bit different than the first 4 problems. Why are they different? What makes them different from the first 4 problems?
Because inequality.
Inequalities, good. So these are solving one-step inequalities. The reason why they're called inequalities is because instead of having an equal sign, they have an inequality sign. We're going to solve them in the exact same manner for the most part. It has 2 exceptions. The first exception Rihanna just addressed. The second exception is if we do what? Yeah, if you multiply or divide by a negative, we flip the inequality sign. So here, how do I get that E by itself? So I'm timesing it by -5. Since I'm multiplying by a negative number, you guys told me the exception to the rule is then I have to flip my greater than sign to less than sign. Then what's -3 times -5? 15. How many of you guys got that one right? Okay, good. All right, last one. 3f is less than or equal to -12. Who haven't I heard from? Isaiah, how do I get the f by itself here?
Alright, you divide it by 3.
Divide it by 3.
And then you do it to the other side. And you cross it. And then you should get 4.
So,
bring your F down.
okay.
and then keep your greater than sign.
Greater than, or is less than or equal to sign the same, you mean? Okay. Then what's negative 12 divided by 3? Negative 4. Nice. Now, because this number over here was not a negative, our sign is going to stay the same. So we multiplied or divided by a positive number. So this sign stays the same. Any questions? Make sure you have all the appropriate work shown. That way you guys get a +2 on your opener.
I thought